In this video, we're going to take a look at a full SAT review for the new SAT. We're going to be looking at Practice Test 1, Module 1. It contains 27 questions. We'll have complete explanations and we'll look at the overall concept that's being used. And we'll solve all of these problems without using a graphing calculator. There are methods that are very useful that we can always take a look at in using the graphing calculator. So let's dive in. Number 1. It's a percentage question. So for most percentage questions, you can actually rely on the idea of is over of equals percent over 100, in case you ever get stuck. We don't necessarily need it for this problem, but let's take a look. It says what is, so the is part is unknown, we'll put an X, 10%, so the percentage gets replaced with a 10 over 100, of 470, so 470 goes in the denominator. So we can simplify this to be 1/10. We can go ahead and cross multiply and get 470 times 10x, and they're equal, and we divide by 10. And in doing that, we end up with an answer of 47. Now, the other thing you would want to know, and it'll match our answer, is whenever you take 10% of a number, you're basically moving the decimal one spot to the left because that's the idea of place value. So another way to see that our answer is 47. And there's also direct translation. The idea of what x is equals 10%, 0.10 or 10/100ths of 470 just means we multiply. So 0.10 times 470, again, is 47. Number 2, what you want to notice with number 2 is it's not asking you to solve for x. It wants to know which equation has the same solution. And we don't need to solve all these. Just notice that they all have 4x in it. So in our equation, we're just going to solve for 4x, and they'll have the same solution. So we have 4x plus 6 equals 18. We'll go ahead and subtract 6 from each side to isolate that 4x. So 4x equals 12. We are done. They'll have the same answer. Number 3 looks like it could scare some people because it has a lot of words in it, but let's just read it carefully and underline keywords and we'll be fine. So we're renting a surfboard and we have a $25 service fee. That just means you pay $25 one time and you're done. But then you're also going to pay $10 per hour for a rental fee. So plus $10 times the number of hours. A person's going to rent a surfboard for T hours, so we're going to use T instead of H, and intends to spend a maximum of $75. Now this can be tricky for some people because maximum 75 realize is going to be less than or equal to 75 because we can't go above it. So don't think it's greater than because of maximum. It's a maximum of 75, so less than or equal to. Fortunately, in this problem, they did not try to trick you. So we basically have 25 plus 10t is less than or equal to 75, and they hand it to you right there. D. Number 4 is a basic look at functions. Realize when you see function notation like g of x, remember that's just the answer when x is plugged in. So you can call that y if you're more comfortable. So it's basically saying we have some function y equals x squared plus 9. And they want to know what is x if y is 25. So we can just plug 25 in for y and solve. We can substitute each of these values in for x and see which one it's equal to. Some of you will see that right away, but let's go ahead and solve it. So we're going to have 25 is equal to x squared plus 9. So we would subtract 9 from each side in solving for x squared. And then to solve for a square, we square root both sides. Now technically, it could have been plus or minus 4, but they're just asking which one of these is the answer. So positive 4 will work, and that's it. Number 5 is looking at a basic probability question. It's talking about a fair four-sided die. And the reason why they say fair is it's the idea of equal outcomes. So there are 14 possible outcomes in this case, and they're all equally weighted. And they have different numbers of 1 through 14. So 1, 2, 3, all the way up to 14. We won't list them all out. If the dice is rolled one time, what's the probability of rolling a 2? Well, the probability of any of these values, since they're all different numbers, has only one possible outcome out of the 14 total. So it's simply 1 out of 14. Now let's just say there was no 3 and 2 was repeated twice, then there'd be 2 possibilities out of 14. So just read the question carefully, and you're going to set up a fraction of the total possible on the denominator, and then with the outcome that you're looking for in the numerator. Number 6, we're looking at a rate problem. So it says it's a constant rate. And when you have a constant rate, we can keep things proportional. So we're going to write this as a proportion. It says it's 42 posters per minute. So I'm going to go ahead and write 42 posters per minute. So I'm going to put over 1 minute. And if this is constant, it's going to always be equal, however we increase this. It says at what rate in posters per hour does the printer produce the posters? So basically we just have to convert 1 hour and just have to know that that's 60 minutes. So we can go ahead and set this equal to 60 minutes in the denominator, and we're solving for what's up here. So we can see for equal fractions, this was multiplied by 60. This would also be multiplied by 60. And if you go ahead and multiply 42 by 60, you're going to get 2,520 posters as your answer. Now, what you can also do, you can also look at this a different way. You can say it's 42 posters per minute. And if you multiply by the total number of minutes, which in our case is 60 minutes, you can see the units of minutes will cancel out, and that will also bring you to your answer of 2,520. All right, now we're just looking at basic idea of function notation. They just word it a little differently here. So it says f of x, I'm going to leave it as a blank, is equal to 7 times that x plus 2. And they want to know what is the value of f of x when x is 4. So that means we have f of 4. So 4 just gets substituted in, and we're only going to work at simplifying this. So we have 28 plus 2, which brings us to an answer of 30. All right, again, another long word problem, but again, we just have to read carefully. We have an assignment worth 70 points. So right away, I'm just going to write down that my total is equal to 70. I like to keep track of these things, 70 points. And it's going to have questions worth 1 point and questions worth 3 points. Okay, so we have 1 point questions and we have 3 point questions. Which equation represents a situation where x is the number of 1 point questions? Okay, so if x is the number of 1 point questions, we'd be multiplying 1 point times the number of those questions. So 10 questions, 10 points, okay? And y represents the number of 3 point questions. So we just multiply 3 times y, and that's going to give us total points, is really what we're looking for. And again, if you notice, all the problems say equal 70, so they kind of tell us that we're totaling for 70. So it's simply 1x plus 3 times y is equal to 70, which matches choice D. Number 9 is looking at right triangles that are similar. So we have LMN and PQR. Now what you want to do here is you should note for similar triangles or similar shapes in general, when we have that symbol, I can go ahead and throw the triangle symbol there, that L will match with P because they're both written first. And that N will match with R because they're written last. And M here will go ahead and match with Q. So when I go ahead and draw my right triangles, I need to label them properly. So let's just draw 2 triangles, and we can draw them the same size, but they're similar, so I'll make one a little smaller. It says L and M correspond to P and Q, so they're telling us that also. Angle M has a measure of 53, so I know for a right triangle that the right angle can't be M. So why don't I just go ahead and call this angle here M, and we can call that 53. And now I'm just going to finish labeling this. We can say LMN, so that means over here L matches with P, Q matches with M, and R matches with N. So there's our similar triangle, and we can see here we have 53. It says, what is the measure of angle Q? Well, we really didn't even do any work here because we know right away that M matches with Q. So in this problem, we could have just looked at the fact that Q is 53, M is 53, so Q is 53 because they all match up. So our answer is choice B. Number 10 is looking at a fairly straightforward system of equations. I'm sure you would have solved these in your Algebra 1 class and even pre-algebra. It's looking for the solution of the system equations. What is the value of x? We're looking just for x. Sometimes they'll ask you different things. So let's go ahead and write down y equals negative 3x. We can see the y is isolated, so that tends to lead us to the idea of substitution. And then we have our second equation, 4x plus y equals 15. So since we have a y equals negative 3x here, we can go ahead and replace this y with negative 3x. So we'll have 4x plus, and I'll use parentheses to be safe. They're not needed here, but it's always good to do. So 4x plus negative 3x, they will combine to be just a minus symbol. So 4x minus 3x is 1x, or x. So x is equal to 15. Number 11 is looking at a scatter plot, and they're looking for a linear model. So basically the idea is if we drew a line down this graph, that fit it the best, which one of these would model that? So we don't need that line there, so we'll take that out for now. So we can really just look at the idea that we have a y-intercept and we have a negative slope. Our y-intercept is positive and our slope is negative. So let's remind you of y equals mx plus b, which I like to see as fill in the blank, y equals blank x plus blank. Right away, we know of a positive y-intercept. So this is our y-intercept here, and this is our slope. So the y-intercepts are positive, so that means it can't be choice A, and it can't be choice C, because those have negative y-intercepts. And then we also see that the slope is negative in this case, right? Because it is going down when you read it left to right. So it can't be the ones with positive slopes. So by default, without doing any real work, it is choice B. Now, in terms of remembering the idea of slope, some people like to look at what we call slope face. Going up is positive slope, going down is negative slope. If you have a vertical line, that's considered undefined slope, and a horizontal line is zero slope. So Mr. Slope Face here will sometimes help you out. All right, number 12 looks a little scary to some people, but it really shouldn't. So we're going to read through this first. So y is f of x, it's shown, so we have a graph. It says it's defined by this function ax cubed plus bx squared plus cx plus d. A, b, c, and d are constants. Okay, how many values of x does f of x equal 0? So really, this is unnecessary information. Some people call it a disclaimer, just extra stuff that we know is going to be true. We can just focus on this. How many values of x does f of x equal 0? That just means y equals 0. So we just draw a line at y equals 0, which is the x-axis, and see how many times it crosses. 1, 2, 3. 3 times. That's it. Our answer is choice C. Number 13, we have another little word problem here. I got Vivian buying some party hats and cupcakes for $71. So it seems to be our total. So we have hats and cupcakes, equaling $71 total. Right? That's our total. We don't know how many of each she bought. It says each package of party hats cost $3. So the hats, we have $3 for each. So we're going to do 3 times the number of hats. And each cupcake costs $1. So $1 if we have a cupcake, we'll just use C. It then says if Vivian bought 10 packages of party hats, so they're telling us, all right, she bought 10 of those. So we have 3 times 10. So we have 30 plus $1 for every cupcake. And that was totaling a total of $71. We can just solve for C. So basically, we're just going to subtract 30 from each side. And we see that 1C or C is equal to 41. So our answer for 13 is simply 41. All right, 14, we're looking at a quadratic, and we do have to know how to factor these. It says, what is one of the solutions to the given equation? Now, there are alternative methods, again, using a graphing calculator, but we're going to look at the traditional algebraic approach. I'm not a fan of writing z down, so I just go ahead and use the x. Z's tend to look like 2's sometimes, so x squared plus 10x minus 24 equals 0. So we have to remember how to factor this when we solve quadratics. So the idea of what I like to call reverse FOIL, where did this come from? X squared comes from x and x. And the two numbers in each of these, we're going to remember, comes from using the middle term and the last term. What adds to 10 that multiplies to negative 24? So I'll go ahead and write negative 24 here and list all the factor pairs in case I can't think of things. A lot of people try to do this in your head, but sometimes it's good to list out. Now, a little trick. This minus 24 means we need to multiply to make a negative, and then we have to add things. So really, it's going to subtract. This A is really going to subtract to make 10. So 1 and 24 can't do that, but 2 and 12 can. And we need a positive 10, so we'd have minus 2 plus 12. Let's just look at the others. 3 and 8, no way to combine them to make 10. 4 and 6 could combine to make 10, but we'd have to add them together, and we have to subtract. We need different signs here. That's why that's no good. So we're going to have x minus 2, and we're going to have x plus 12. When you finish solving this, you set each one equal to 0. And remember, they're only asking for one possible solution, so we can use 2 as an answer, or we can use negative 12 as an answer. A lot of people like to play it safe and go with the positive value of 2, and that's all there is to it. Number 15. All right, we have bacteria growing in a medium. So usually when they talk about bacteria, you're looking at exponential growth. It's no longer linear. It says there were 300,000 cells per milliliter during initial observation. So initial, let's go ahead and write this down. There was 300,000. I won't bother putting labels on this just yet. It says the number of cells per millimeter doubles every 3 hours. So doubles every 3 hours, doubles every 3. Let's get that down. This how many cells per milliliter will there be in 15 hours? So we're going 15 hours. Now we could set up an equation here, or we can just kind of think our way through it. So 3 hours, after 3 hours, it's going to double once, and then at 6 hours, at 9 hours, 12 hours, and again at 15. So that means 1, 2, 3, 4, 5 times it's going to double. So we can take our 300,000 that we start with, and when you double something, obviously we're multiplying by 2, and we're going to do this 5 times. So we can just do times 2, times 2, times 2, or as many of you know, that's just raising it to the power of 5. And if we go ahead and do this, this one we probably do want to go ahead and just type it into our calculator to see what it is. And if you do that, you will get 9,600,000, which is choice D. Now, for exponential equations, what you're going to want to know is really this format. Y equals the initial amount, goes in here, times whatever our base is. If we're doubling something, it's going to be a 2. So for now, I'm just going to call it A, but usually it's a 2 if we're doubling. And then up here is our t, or our time, or the number of times we're going to do that. Number 16, we're looking at a polynomial expression that's being simplified, which one is equal. Now, if you ever get stuck in these, you can always just pick a value for x, let's say 1, and a value for y, 2, although it's dangerous to use the 1. You might want to try a 2 or a 3 or something. Plug them into your calculator and check each one. We're going to be more traditional here, and we'll take a look at the 6x to the 8th y squared plus 12x squared y squared. So we notice that they're raised to different exponents, so we can't combine these to a single term. And both a and b have a single term, so we're going to scratch those out. So we're between choice C and D. So we could go ahead and distribute and check each of these, but let's look at the traditional way to do this. We're supposed to look at each term and see what they have in common. Both 6 and 12 have a 6 in common, so that will be factored out. X to the 8th, x squared, so we can take out x squared because that's true of both of them. And then y squared is in both, so we have y squared, y squared. And you'll notice they have the same thing written there, but the question is, what are you left with when you factor this out? So we have 6x squared, y squared. So we're going to want to remember our exponent rules, and the 6's cancel. So x to the 8th over x squared is really what we're keyed in on here. So for division, you subtract exponents. So that's the rule here. X to the a over x to the b will always be x to the a minus b. So we're left with x to the 6. So we can stop right away. We see our answer is choice C. If we keep going, we'll just see that 12 over 6 is 2. X squareds cancel, y squareds cancel. So exponent rules will be a key piece for you to look at. Number 17, again, they throw in some words or measurements sometimes you're not used to. You can ignore them and just use something you're familiar with and just really focus on the numbers and what exactly they're writing down. So we have a neighborhood consisting of a 2-hectare park. So we're going to do this. So instead of acres, they're looking at hectares. And a 35 hectare residential area, so 35. So we have a park, so we have to distinguish between the two, and a residential area. We'll just write res. The total number of trees, so we're looking at trees equaling 3,934. Then they actually give us the equation. They say we have the equation 2x plus 35 y equals 3934, but they want to know what's the interpretation of x. So we're equaling 3,934. So that is trees. So we're going to be doing 2, and then we have hectares, right, times x, plus the 35, we can see hectares times y equaling 3,934 trees. So we want our answer to be trees, whatever we're multiplying by. So our issue, it's these hectares, this h, we don't want that. So whatever we multiply with x has to cancel that out. And we do want an answer of trees. So that means we want x to be trees, because that's what we want. And that's going to need to cancel with the h, or the hectares. So it's trees per hectare. So that will cancel out. And then if we're talking about the x value, the x is the one associated with the 2. So that has to do with the park. So that's got to be trees per hectare in the park, which looks like it is choice A. So with unit cancellation, that's what's going to help you. The fact that you wanted trees, you had hectares, if you want them to cancel, that's in the denominator. And whatever you want to be left with will be in the numerator. Number 18, looking at another linear graph. This one's a little bit different. They're asking which equation could represent this relationship. So let's go ahead and make it obvious that here we have x and here we have y. And there are different ways we can go ahead and do this. So they do have two equations, both choice A and C written in mx plus b form. Now, we remember mx plus b form, blank x plus blank. That second blank is the y-intercept. Now, clearly, the y-intercept is not 12 or 8. Up here we have 40. So we're just going to go ahead and cross out A and C right away. So now it's a question of figuring out B and D. So what we can do is really look at the idea of x and y intercepts. That's what we're going to do. So let's go ahead and just do x, y, a little trick here. And we see that the x-intercept looks like it appears to be 60, and that's when y is 0. And the y-intercept is 40, and that's when x is 0. So we can just plug in to see which one of those would work if we wanted to, or we can go ahead and take a look at slope and solve things out. But let's just go ahead and plug in. So if we try choice B, we would have 8 times 60 plus 0 equals 480. Well, that's true. And then try our second point here, because we wanted to make sure it's true for both. 8 times 0 plus 12 times 40 equals 480. Well, that's true for both, so that's going to work. So just by identifying the intercepts, we could substitute in and get those answers. Now, there is another way you can do this. It's usually not taught in most classrooms, but it's called intercept form, if you want to take a look at that. It's always x over the x-intercept plus y over the y-intercept equals 1. So in this problem, we could have said x over 60 plus y over 40 equals 1. And then what we'd have to do is we would clear the denominator. So we would just multiply, we can multiply by what both 60 and 40 goes into. In our case, you might have noticed that we have 480 in both of those. So you can go ahead and multiply by 480. and then just see what happens. And in doing that, you're going to end up getting 8x plus over here 12y equals 480. So different form in case you haven't seen it. Number 19. All right, we're looking at a circle with a radius of 3 ends. Let's go ahead and sketch a circle here. See how well we can do that. And we have a radius of a little shaky, but we'll go with it. We have 3n. So this is circle A, so I'll go ahead and label that A there. And circle B is much larger, so we'll pretend that's much larger. All right, so here we go, circle B. And that radius, it says, is 129n. It says the area of circle B is how many times greater? Well, we don't have the area, but we can look at the idea of the radius and see how many times greater. So when you want how many times greater, just in general, we would take the larger one and divide it by the smaller one. So we see the ends cancel out, and we do 129 divided by 3, which is 43. Now, careful, that is an answer, but that's not the answer we're looking for. The radius is 43 times greater. Now, realize if we were to go ahead and find area, we could do pi r squared. But whenever you look at something linear versus the area, you multiply that ratio twice, okay? So think about a square might be easier to see. If you have 12 inches, 12 inches, it's the same thing as 1 foot, 1 foot. We see it's 12 times greater, but when we find the area, we have 144, and here we have 1. So it's times 12 times 12, and it really has to do with that squared. So what you're going to do, if you find a linear ratio of 43, to get the area, you just do it twice. 43 times 43, which will be 1,849 right there. Now, if that n was bothering you at all, you can choose a value for n. You can make n equal to 1. You can make n equal to 2, 10, whatever you like. So if you just say let n equals 1, and you want to go ahead and find that area, you can go ahead and do a equals pi r squared, right, for that one. And down here is the same thing, a equals pi times 129 squared. Look at those values and divide, and after you divide, again, you'll get 1,849. All right, number 20 is actually a pretty basic question. They could do many different things with a chart like this, so it's probably be important we take a look at what exactly we're looking at. It's a frequency table looking at 57 data values. So 57 is our total number. So all these values in frequency, meaning how many times it shows up, should equal 57. It says, what is the maximum data value? Well, these are our data values, and it goes up to 14. So our answer is simply 14. But let's see what exactly is going on here. This is the idea of line plots or histograms. So we'd have the number 6, 7, 8, we'll go all the way up, and we'll say 13 and 14. So what's going on here? It says data value of 6 is a frequency of 3. So we mark 1, 2, it's 3 tall. 7 is also 3. And then 8 is 8 tall. 1, 2, 3, 4, 5, 6, 7, 8. So again, we can finish this whole thing. I'm not going to go ahead and do that, but realize this is something you can set up if you get stuck looking for, what's the maximum value in terms of what has the most frequency. So we can see here 11 has 11. So different things can be done with that. Number 21, we have a circle in the xy plane. They give us the endpoints and they give us an equation. So first, let's go ahead and write down the equation of a circle in case you don't know it. Using coordinates, that is going to be x minus some value squared plus y minus some value squared equals the radius squared. So basically this right here, this x and y, that's your center point. Usually it's referred to as HK. So let's go ahead and write that down. And this over here, whatever squared, is your radius. So some of you'll notice it's just a Pythagorean theorem. Now we may not need any of this, but that's the information you want to know. Whenever I have something with points, I do like to go ahead and make a quick little sketch just to see what it is I'm looking at. You'll find this is helpful. It says our endpoints are at 2, 4, so we'll call that 4 right here. And then 2, 14, so up here is 14. Now, if those are endpoints, and we have a straight line, we can see, okay, that's the actual length of our diameter. We can also notice if we needed, what the center is going to be, that it's going to be over 2 up 9, right? That's halfway, so there's our center. So our distance here from 4 to 14, that's our diameter, is equal to 10. So the radius is simply equal to 5. Now, some other things you could have done is you can always plug values in to solve for things. For example, here we have the value 2, 4. So we can plug that into x minus 2, so 2 minus 2 squared, and our y value was 4. 4 minus 9 squared equals our radius squared. So this would be 0, so we'll get rid of that. 4 minus 9 is negative 5. Square that, we get 25 is radius squared. Square root each side, since we're dealing with distance, we can only have a positive value, so our radius is 5. So another method to get there. All right, number 22 is taking a look at measurements of angles, but they're using radians instead of degrees. So if you're not familiar with that, the key piece of information here is that pi radians is equal to 180 degrees, or 2 pi radians is equal to 360 degrees. And then there's a whole bunch of other little ones we can look at, but let's just go ahead and see what the question's asking. It says the measure of an angle R is 2 pi over 3 radians. All right, so usually when we measure angles, we like to put them on grids like this. So I'll put the first part here. Now 2 pi over 3, I can plug that into my calculator to figure it out, or some people do know that pi over 3 is equal to 60 degrees, and it says there's 2 of those. So it's going to be 120 degrees. So we'll just go ahead and estimate that right here. So this looks like what angle R is. So angle R is coming around like that, 2 pi over 3. And if you didn't know what this is, that's fine too. We just draw an angle. Then it says the measure of angle T is 5 pi over 12 greater. Now, that's not a common value for most people, although some people might know that pi over 12 is 15 degrees. But again, you have a calculator, you can do 5 times 180 divided by 12. But we're just going to go a little bit further, that, that T is 5 pi over 12 greater, so it's going to be this much greater. So 5 pi over 12, that will get us to angle T. So really what you're doing is just doing 2 pi over 3 plus 5 pi over 12. If they wanted the answer in radians, we would just go ahead and add 2/3 and 5/12 and have the answer in terms of pi, but they want the answer in degrees. So you can go ahead and convert that, and for each one, so you can just do 2 times 180 divided by 3, type it in your calculator, 5 times 180 divided by 12, type it in your calculator, and add them together. And when you do that, you're going to get 195 degrees. Now, another way you can do this is some people are just comfortable with these values, usually in the end of an advanced algebra course or in a pre-calculus course. They're fairly comfortable, and they would just know that 2 pi over 3 falls in this quadrant here, and 5 pi over 12 is less than 90 degrees. So the only answer that would actually make sense is choice C, is another way to look at it. All right, in 23, we're also looking at area. So we're going to use a similar idea that we had earlier. It says a town has an area of 4.36 square miles. Now, it doesn't say what the shape is, but let's go ahead and just draw in a square. It really doesn't matter. And then we can know that whatever we multiply each side by would be 4.36 if it was square. It says, what is the area in square yards? So we can go back and figure out what the length was in miles and then convert that to yards. They tell us what this is here, but realize that when you do this, if you did yards times yards, and we know there's 1,760 yards, 1,760 yards, what we're really doing is multiplying by 1,760 twice. So remember, whenever you go from linear to area, use that value twice. So if we had 4.36 square miles, and there's 1,760 yards in each one, we can just multiply by 1,760 yards per mile twice. And you can see what happens here is you'd be squaring the miles. That gets it to cancel, leaving you with square yards. And when you do 4.36 times 1,760 squared, this is a large number. So some people might just go ahead and guess that that's the value right there. Question 24, we're taking a look at a line. This seems a little different. It says line H, the table shows 3 values of X and their corresponding values of Y. Line K is the result of translating line H down 5 units. All right, so a lot going on. So we have line H, and then K is equal to H going down 5 units. Okay. And they want to know what is the x-intercept. So they're going multi-step here. So we want the x-intercept of K. All right, so what we can do is we can go ahead and find the equation for line H. You know, we can sketch this out also if we really wanted to, just to see what's going on. We have points 18, 130, you know, so that's way up there. 26, 178, that's up here. So we do see that we have something with a positive slope, and that's going to be shifted down 5. And then we have to find out where it crosses. So let's go ahead and find the slope of line H. So we're looking at line H right now. So 130 to 60, it went up 30. 18 to 23, it went up 5. So we can see the slope for H is 30 divided by 5, or 6. And then we can go ahead and just write the equation. Y is equal to 6. And then we use point slope, so we're just going to plug in a point. So 18 plus 130. In case you didn't know that, let's put that up here. So the slope, x minus the point, plus the y value of the point. So we just plugged in. Now this is line H. And then what we're supposed to do is we're supposed to move this down 5. So that just means subtract 5. You know, we just have to do that to the outside here. So line K is y equals 6 times x minus 18. And this will be plus 125. And they want us to find the x-intercept. So x-intercept means when y is equal to 0. So we're just going to go ahead and plug in 0 here. At the same time, we can distribute. We don't have to, but I think most of you would. So I'll go ahead and do that. We'd have 6x minus 108 plus 125. We can combine these terms, and we end up with 17. So we have 0 equals 6x plus 17. And we can kind of start to see our answer here already. We're going to end up subtracting 17, right, to one side to equal to 6x and divide by 6. So we see our x-intercept is negative 17 over 6, which is choice D. Number 25, we're looking at a quadratic intersecting some line at one point. So for a quadratic, most of you should know it's the shape of a parabola, which most of us draw like this. But when we look at it in standard form, which is ax squared plus bx plus c, I'll do it with blanks. If this a value is negative, we know it's concave down or opens down, some people will say. And if it intersects at just one point, there's only one way that can happen. It's going to hit it at the vertex up top here. So really what they're asking for is they want the value of the vertex, and if it's at y equals c, they're looking at the y value. So we want the y value of the vertex. So there are calculator programs that'll find that for you, but if we do it the traditional way, if something is in standard form, the x value of the vertex is always negative b divided by 2a. So here's a, here's b, here's c. So in our problem, we would have negative, and our b value is 9. That's in our coefficient of the x. 2 times a, it's just negative or negative 1. So 2 times negative 1. So we get 9 halves. So we have 9 halves. So part D, this seems to be a distractor. Don't want to eliminate it right away, but probably not going to be the answer. And now when we go ahead, we just go ahead and substitute the x value in to find the y value. So it'd be y equals negative, and we're going to have that x squared plus 9 times that x value minus 100. So if I substitute that in, 9 over 2, 9 over 2. Again, we can go without a calculator. We can plug it in our calculator. So without our calculator, we can square this. We'd have negative 81 over 4. And then here, we're going to have plus 81 over 2 minus 100. If we're going to do this without a calculator, we can say minus 81 over 4. Common denominator, we need a 4, so multiply by 2. And we have 162 over 4. And if we rewrite 100 using 4 in the denominator, that's 400 over 4. And we just do negative 81 plus 62 minus 400, which brings us to negative 319 over 4. Again, calculator will make that easier, but there's something satisfying about doing it by hand. Number 26. All right, again, we're getting harder and harder here. Remember, towards the end, they do get more challenging. It says, for each real number r, which of the following points lies in the graph of each equation in the xy plane given the system? Okay, so basically, they're looking at the solution of these two, but something that you should notice is that they are the same line. That's what makes this a little different. If you did 7 times 5, you get 35, and 2x plus 3 times 5, you get 10x plus 15. So let's just write down the simplest version, 2x plus 3y equals 7. So most of you would know this as infinite solutions, but they're saying, you know what? How can we write those generally speaking? Like, what are the answers? So what we don't know, are they saying that x equals r, or are they saying that y equals r? And why I mean by that is right here we have y equaling r, we have x equaling r, we have x equaling r. So because two of these have the x value as r, I would probably go ahead and try that, but there are some ways around this too that you can do that you could notice. You'll notice that we're going to be multiplying by 2 and 3, and then down here we have denominators of 2 and 3. So there's something going on with that. But let's go ahead and just try real fast x equals r to see what happens. So we're just trying this. So that means we'd have 2 times r plus 3 times y equals 7. And if you solve for y, we're going to subtract the r from both sides, and then we end up dividing by 3. So this means y would be negative 2r over 3 plus 7 over 3. Well, that's 2r over, it's not negative, so it's actually not choice C. And it can't be choice D either. So now I'm between A and B. I would guess B, but let's go ahead and do that out. So that means we're going to try y equals r now. So if y equals r, we would have 2x plus 3r equaling 7. We're going to go ahead and subtract the 2x, and we end up with, we're going to subtract the 3r from both sides because we're solving for x, and we have 2x equals negative 3r plus 7, and then we divide by 2, and we end up with negative 3 over 2r plus 7 over 2, which is what we have here when y was equal to r. So choice B is our solution. Last one. We have the perimeter of an equilateral triangle is 624. So equilateral triangle, you should know that all 3 sides are equal and all angles are 60 degrees. So that means we know what the side length is. We just do 624 divided by 3, and we have each side equaling 208. It says the height of the triangle is k over 3. So there's our height. So let's redraw one of these triangles that's hidden inside. And we have k over 3. So that would be a right angle. What is the value of k? Well, this is 60 degrees, and this was one of our sides here. That's going to be 208. So what they're really having you look at is the famous 30, 60, 90 triangle. And what you want to know for that is usually across from the 30 we call x, or I'll call box. Across from the 60 would be whatever's in there times root 3, and what's across from the 90 is 2 times that value. Well, here we can see that 2 times the value matches with the 208. So whatever goes in that blank there is 104, because 2 times 104 is 208. So this value here would be 104, and this would be 104 root 3. So the value of k is 104.